finally, let's talk about some real-world applications. First of all, we'll talk about restricted domains. There are a lot of cases where only certain numbers are really reasonable. For example, negative 250 cars being built at a factory is not a reasonable number. 3.6 people in a family is not a reasonable number, even if you have a baby or even if there's somebody that only lives there part of the time. They're still a whole person. So when you have certain domain values that you can or cannot include in a problem, we can say that the domain is restricted. For example, in this function, we have restricted the domain to x is greater than or equal to 0. So the only values we're interested in would be the ones where the value of x is greater than or equal to 0. Take a look at what will happen in the table if we use only positive values for x. Well, the y values would start at 4, but then they would go down from there. Looking at the graph, you can see that you're coming down from the value y is equal to 4. It will continue on past that, but it will never go above positive 4. So when you look at the range, we can see from the graph here that all of the points will be 4 or less, and we can say that the range of the function is y less than or equal to 4. Take a look at the graph of this function. You could graph that on your graphing calculator, or you can plot a table of values to come up with it by hand. But either way, what we're interested in here is the domain being x less than or equal to 0. I've highlighted on the graph the x values that are less than or equal to 0 with the yellow highlighting. Now look at the line and you'll see that the green portion would be the portion of the line that fits this domain. What's the range of this function? Well, the range of this function would be the values positive 1 and anything larger than that. So we would say that the range of this function is y greater than or equal to 1. Another example. The distance in miles that a runner travels is given by the function d equals 6t, where t is the time and d is the distance. The runner is going to go for a 1.5 hour run. We'll graph the function and identify the domain and the range. First of all, is this particular problem telling us domain or telling us range? Well, they're saying that the time has to be no more than 1.5, and logically it can't also be less than 0. So they're limiting our domain, and we can say that the domain of the function is everything from 0 through 1.5 inclusive. If you make a graph of this particular function, you'll see that the domain starts at 0 and goes through 1.5. You can plot those points on the graph to see the path of the runner. Now, to determine the range, we're going to look at the y values on this graph. The lowest y value is 0 when he hasn't run any yet, and the highest y value is 9 when he's finished his 1.5 mile run. So you can see from this graph that the range of the function is all numbers from 0 through 9 inclusive.